Hello everybody, Adam Lusek here, and today we're going to talk about how to make successful and improve existing AI-related products. By now, you've probably seen the headline that 95% of Gen AI pilots at companies are failing, and as someone who spent the last couple years developing, deploying, and scaling successful AI products, I want to talk a little bit about how to land yourself in that successful 5%. To provide a little bit of context, I think one of the issues that's come about with the advent of language models is that it's become very easy to create a lot of pilots and proof of concepts of things that could work. You can very easily and very rapidly qualify to a degree whether or not an idea will work by simply just sending something to a language model API. A simple message in and a output back can show you a direction to take and that an idea of yours might be possible. For example, you might be interested in doing some form of niche reporting for your specific domain. You throw in a bunch of text related to what you want to report on, and the language model spits back what seems to be a decent report for you. This gives you a decent indication that your idea is possible, and so you may spend a little bit more time doing something like tweaking the prompt that you're running this information through and getting it to a degree where you feel that the output from your proof of concept is pretty decent. But with this, there remains still a few issues. How do you actually take that initial proof of concept and scale it into a successful product? And how do you actually quantify whether or not the output that you're getting is actually decent? If you have managed to take your proof of concept through to deployment and start having users actually use your product, you've probably ran into a similar situation that Shreya Shankar here outlines in the blog Short Musings on AI Engineering and Failed AI Products, where down here she mentions that teams often expect too high of accuracy or alignment with their expectations from an AI application right after it's launched, and don't often build out the infrastructure to continually inspect data, incorporate new tests, and improve the end-to-end systems. It follows, and I've seen this time and time again, a little bit of this downward curve of initially deploying your POC and what seems to be working. You have no way of actually measuring whether it's aligned to users' expectations and whether the output that you're getting is decent. And then we run into something like this where we get feedback that the AI doesn't work or that users can't deal with the inherent randomness of the outputs that you get from a language model. We know by now that language model behavior and output are, by nature, stochastic and subjective, meaning that given the same inputs from different users, it's likely that the outputs or actions taken by a language model are going to differ in some regards. Thus, the output is relatively subjective and open to the judgment and interpretation of whatever user is using the system. This gives us a bit of a unique challenge where we can't really employ a lot of the traditional software-based testing and quality assurance techniques because the output generated is just so different and non-deterministic. So to actually start to define what to measure and what to optimize against to actually make measurable improvements in our products, we need to properly do three specific things. First is define our metrics alongside development, transition our evaluation and success metrics from technical to user-centric measurement, and finally, we need to look more at the trajectory, which is often referred to as the trace of the language model system that we are building. On the third point, getting to a final output from an AI or language model based system requires a lot of different steps to interact with each other with varying levels of complexity. So from input of your prompt through your system to the final generated action or output, any sort of bad output could be a result or attributed to something like the language model's core reasoning and intent understanding of the prompt, the way that it selected and inputted its various keyword arguments into the tools, how it actually observes and interprets the responses back from any given tools, your RAG or retrieval or context engineering based performance, if you're in a multi-agent system, whether or not these agents are effectively communicating and interpreting the output from each other, the opinion of just the flat out user who is reading the output or looking at the action of the system, as well as the user's trust in this system and application as a whole. And I list all of these to make the point that language models' real operational style of doing this react or reasoning, acting, and planning style of solving problems is what makes it very useful. However, at the same time, what makes it very tricky to actually debug and interpret and make improvements for. With working with these intelligent systems, we often liken them to having something like an intern or an employee that we are managing. We may look at and evaluate a language model's performance similar to how we do any form of human performance reflection. Things like asking, do they understand the task? Do they take the right steps to get to the output? Do they come to a conclusion in an efficient manner? Do they have the right tools and resources? Is their quality of work expected? So on and so forth. I always find it a little bit amusing how similar actually assessing and improving language model systems are to being able to observe and give good feedback towards people. Being some form of hopefully intelligent system or being requires you to do a lot of this fuzzy evaluation to make certain improvements. I often also ask myself a lot of these same questions when observing the way that I operate and how I'm improving in my own daily life. And just like language model systems, we also need the right tools and frameworks to be able to assess and make those meaningful improvements in our day-to-day, which is why I'm excited to be partnering with Brilliant. Brilliant helps you excel in math and computer science with visual, interactive problem solving and personalized practice. Regardless of whether you're already an expert or just getting started, Brilliant's unique learning style lets anybody become a math and science person. My favorite part about Brilliant is that you learn through active problem solving, taking on a mix of interactive and motivating challenges to reach your specific learning goals. Crafted by professionals from places like Harvard, MIT, and Google, Brilliant's courses are curated to help you realize your mind's full potential. It's great to see that they have diligently crafted lessons on cutting-edge topics like artificial intelligence and quantum computing. They make learning even more effective by personalizing it just for you. Through custom designed practice sets and reviews that are personalized based on your performance and confidence level, you can learn and advance at your ideal pace. With Brilliant, anyone can be a math person, getting hands-on experience with concepts until they make sense. Not just memorizing formulas, but helping you develop the intuition and problem-solving skills to figure these things out on your own. So to learn for free on Brilliant, go to brilliant.org/AdamLusek, scan the QR code on screen, or click on the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks to Brilliant for sponsoring the video. So with this understanding that evaluating and improving language models is a little bit different from what we usually do, this brings us to our second point that we need to transition our evaluation and success metrics away from technical to user-centric measurement. Essentially, we need to fundamentally change how we evaluate as a whole. An interesting way to think about this comes from Google's white paper on agent quality linked here, where they claim that traditional software verification asks, did we build the product right? It does stuff like verify logic against our fixed specification, whereas modern AI evaluation asks, did we build the right product, using a process of validation, assessing quality, robustness, and occasionally trustworthiness with our users. So in other words, to improve our AI behavior, we care a little bit less about the signal of whether the system actually performed or not, and more about digging into the value that the system provided and how that aligns more specifically with our user base's expectations. Doing this effectively, however, is a lot easier said than done, as measuring the value of language models' outputs and the processes that they are defined by remains incredibly subjective, application-specific, and requires a lot of pre-work for actually setting up this whole framework so that you can make measurable improvements to your product. Although the result and, of course, pitch of this work is that in following a lot of these practices and doing these different steps and setting up this robust framework, you can actually make measurable improvements and ensure that your AI-related product is actually successful rather than falling into that 95% pilot failure range. So for the remainder of this video, that's what I'm going to be going over. How I actually set up and operate a lot of these different evaluation techniques and measurement techniques to drive successful implementation and deployment, as well as all of the various different benefits that you can do once this infrastructure is set up. So first, we must define what I mean when I say language model evaluations. What may immediately come to mind is a graph that looks a little bit something like this, that's usually released whenever a major model is published. We get these wonderful looking charts that have things like agentic terminal coding, 59.3%, novel problem solving, 37.6%, and they're all compared across the various state-of-the-art models. And while these are benchmarks and evaluations of the language models themselves, I often see teams look at these and think, well, what does this actually matter for my specific product? It tells us a lot about the different performance between the various models on some sort of standardized benchmark, but less about how that model is actually going to perform and how our specific application, which may be relying on the reasoning engine of one of these models, will perform as well. But that is not to say that these styles of benchmarking and evaluations are particularly useless. This is, of course, what a lot of the more AI lab related work does to measure the actual competency of their models as they are training them and fine tuning them for release. Benchmarks like GPQA Diamond here measure things like graduate level reasoning in the models, and you can see a bit of a comparison here, but tends to correlate a little bit with the actual learned intelligence. And of course, a lot of these models are also benchmarked on their development practices with things like SWE-bench here that measures the ability to solve real GitHub issues. So while a lot of these metrics don't actually tell us our specific application performance, we do benefit from the fact that these have been extensively benchmarked and optimized. The fact that language models can already do things like follow instructions, perform tool calling, understand and answer questions, code effectively, comes from the implementation of these aforementioned measurements. What you usually don't see, however, from the release of these charts is all of the work that's been done to actually set up these effective evaluations and benchmarks. Luckily, however, we can actually take inspiration from how the folks training these models do it and apply some of the same different approaches to actually implementing these things into our own specific applications. And among most language model application related benchmarks and evaluations, there tend to be three primary approaches. We have the human feedback approach, language model as a judge approach, as well as regular old functions. And all of these styles of measuring and evaluating are not independent of each other. I would say they are more interdependent. Often, much of these feed into each other or defining the other and serve various purposes along the life cycle of actually evaluating and measuring language model application performance. They also evolve generally as your application is being developed, tested, and created. But from where these evaluations are actually defined and where most of the work actually happens tends to be gathering what is often considered the gold standard and most important kind of feedback that you can have, human feedback. Gathering and analyzing human feedback is where I honestly spend the majority of my time when I'm assessing the performance of my AI systems, as well as trying to figure out the direction in which to improve them. And so of this, a few different commonalities have emerged. As with most human feedback, the idea behind it is pretty simple. How do you know if someone likes what you did? You ask them and you get their opinion and you get their feedback on it. And with this, we hope to make some sort of informed decision. And it is through the collection and repetition of this process that generally you are able to figure out what is most valuable to the users that you are supporting and what you should be focusing on in your development. Nothing completely new, but there's a little bit of nuance when applied back towards language models. Ideally, the system that you're actually trying to improve already has some sort of overarching purpose that you've done some form of evaluation or requirements defining to get to. In other words, you should have an idea about the ideal end state that you're trying to optimize towards. For some quick examples, if that doesn't make any sense, a flight booking agent or AI system should be able to successfully book a flight. A customer service agent should be able to effectively service the customer in the ways that it is expected to, and something more niche like an enterprise workflow automation agent should be able to successfully complete what is trying to be automated. So with this, we're going to follow a bit of a process. Once we have our features and purpose, which are of course defined through our initial requirements gathering and building all of the wonderful pre-work that comes with creating software, what we're going to do is consider all of the end user scenarios and personas that we want to support. This may be something like, in the case of a customer service agent, someone wanting to do a return, someone who wants to check on the status of their order, someone who is brand new and has no clue how anything works, someone who is very familiar with the platform and is trying to find maybe something niche about product information, so on and so forth. Doing some sort of persona-based defining and analysis is pretty common when we are creating software in general, so hopefully you can rely on a little bit of that pre-work that you've done to be able to take it to this next step, which will be collecting or generating diverse sample queries for each one of these scenarios and personas. This is usually done by using our proof of concept's performance as our baseline for our human assessment, and also a vehicle for determining what's useful to measure or not. In other words, we must observe our initial state's performance. One of the common pitfalls that I see is actually trying to define some of these metrics before we even have that baseline or proof of concept to assess against. This creates a sort of race condition or chicken and egg kind of scenario where we don't really even know effectively what to analyze or evaluate until we have something. So it's best to do more of the initial development than put in the effort of creating a robust evaluation suite so that we can truly target what is useful. So usually you'll have that proof of concept, and given our set of sample queries or prompts that we generate based on our scenarios and personas, we are going to run those through and log our inputs and our outputs together. This creates our initial, what I call evaluation exploration dataset. It is recommended, especially for getting the most out of this effort, to collect somewhere between 20 to 100 example queries as our starting set. Now, I would argue that we want to be maybe closer to that 100 range, but not necessarily excessive because we don't want to overwhelm our annotator, which is who we're going to be employing in a second. With our diverse set of input-output queries and responses, what we need to do then is observe and do some sort of human judgment on this set. But this is also where a little bit of friction comes in. So for the more technical among us who might be building and creating these systems, we tend to have a lot of the technical expertise. I myself operate as more of an AI specialist within a larger organization, and so my specialty is, of course, the AI side of things, applying and understanding and being able to help the organization with all of that. I am not, however, the expert in the domains that I am applying a lot of this artificial intelligence to. That is where we must rely on a third-party subject matter expert to get their professional opinion. It may be tempting, and you may think that you have a lot of this expertise to be able to annotate the inputs and outputs, but I have seen that the most effective and most useful information comes from actually partnering with an expert in the domain that you're applying to. So for something like a customer service agent, you might want to talk to someone who is directly leading or managing a lot of these customer service efforts, knows the playbook in and out, and understands the situation that your agent or product should be operating within. Given their experience and expertise, they are the ones whose opinions on how the system is actually performing are going to be the most crucial and also help us get the best direction towards what to optimize and what to look for. So with your newfound friend, the SME in the domain that you are applying your AI application to, what you're going to do is task them with looking through these input prompts and output responses and indicating whether or not they are a pass, a fail, good or bad, acceptable or unacceptable, and then providing also some robust qualitative feedback. We're not going to do anything too crazy at this moment with various individual metrics. We really just want to see whether or not something is passing or failing, a very binary indicator. At this point, it may be tempting to, instead of having a binary pass-fail, ask them to do something like rate this on a scale of 1 to 10 or 1 to 5, something like that. But the issue with these scales is that they don't necessarily tell us anything super meaningful. The difference between a 2 and a 3 and the difference between a 3 and a 4 is very different to pretty much anybody and difficult to interpret as well. But it's very easy to identify whether or not something has passed or failed, and very easy to interpret that. So as a general rule of thumb, rather than trying to have something on a scale, we want to employ more binary indicators as they are much stronger signals of performance. On the topic of the qualitative feedback, we want to encourage these SMEs to almost write a decent amount as to why they think something has succeeded or why they think something has failed. This will be super critical in the evaluation that we'll be doing in a second. And over the time that I've been collecting human feedback, I've seen that most of the issues and most of the specifics that I never even consider, which is the reason why we're talking to these SMEs, comes up when they're actually providing this robust qualitative feedback. Bonus points if you can get them to do the even more difficult task of providing what the expected output might be from the input. Although not necessary, this does provide almost the best form for especially us developers to start optimizing against that. However, for this exercise, that's not 100% necessary and tends to add a lot of overhead. So if you've got a very agreeable SME, maybe you can get a few of those from them. So assuming we were able to get the annotated input outputs as well as the feedback from them, what we can do now is perform what has been defined as error analysis. I've adopted this specific definition of error analysis from Hamal Hussein here, who wrote up this great blog on a field guide to rapidly improving AI products. At its core, this is nothing more than really looking at the instances where our system is failing and then clustering the failure modes across our common themes. This is where we're going to start to see, as we process and look over the feedback from our initial annotation, the individual and specific to our product pain points, which actually cause the system to not be up to the standards of our expert. This goes back to the point that I was discussing about how the actual metrics that you define and evaluate should come in tandem with your development process. Put a little bit more succinctly by Hamel himself here, he mentions that your evaluation strategy should emerge from observed failure patterns. This allows us to get right to the core of what is actually acting up within our system so that we can address it effectively. On top of all of this, we also need to be aware of this concept of criteria drift, which comes from this paper, Who Validates the Validators? They mentioned that we observe a catch-22 situation. To grade outputs, people need to externalize and define their evaluation criteria. However, the process of grading outputs helps them to define that very criteria. They dub this then the phenomenon of criteria drift, and implies that it is impossible to completely determine evaluation criteria prior to human judging of LLM outputs. So through actually observing all of the failure modes and looking at the feedback from your SME, this is where you'll start to surface all of these pain points and explicitly define them as things that you should be evaluating and measuring. It's already likely that you're doing some form of this in some manner already as you're developing your product and looking at the inputs and outputs naively, but this makes it a little bit more official. For an example of how I've done this recently, the other day I was looking at some reports generated from my deep competitive analyst agent and noticed that there was some sort of lack of relevance of citations. I would identify that these reports would be failures in the annotation process, and my feedback would be, of course, then that the citations are irrelevant or don't seem to capture the full scope of what I was hoping. Further analysis of the trace led me to find that the issue was with how the language model was behaving when it was calling the internet search tool, where my web API was expecting more of a natural language input to do the search, and it was very much adding all sorts of different search engine results page style filtering. So if we wanted to be even more specific, we could say adherence to the search tool's expected query style would be a metric to evaluate, or we could keep it a little higher level as the relevance of our citations here. But with this process of generating, annotating, and observing, what we can do is begin to group our similar failure modes together to categorize them. These, of course, become our candidates and definitions for product-specific evaluations. And these various definitions are going to become, as we build them out a little bit further, much more useful than looking at some of the more generic definitions of various different metrics that we may see fly around online, things like helpfulness or hallucination rate. While these metrics are actually valid, the issue is that they are not defined and scoped specifically to our product, which is what we are trying to do more specifically with this effort. One of the assumptions that we make at this point is that the feedback that we've collected and thus defined our evaluation metrics from our SME that we've employed is actually representative of what would be useful to optimize against. In other words, we are assuming that optimizing for these metrics will be an effective use of our time, as they are what's been identified as critical and important to a subject matter expert whose opinion we extend as our almost best indicator of what will be beneficial for the masses. So at this point, with some of our surfaced evaluation metrics defined, what we can do is, if things are relatively an easy fix, we can go ahead and push a hotfix, change a prompt a little bit, and try and address them. If that does solve most of the issue, then we're good. But for those failure modes that still persist even through a simple hotfix, we are going to officialize those as our metrics to evaluate. At this point, it's beneficial to do another round of annotation, where instead of just having a pass or a fail, we list out our various metrics that have been surfaced and then add pass-fail labels for those. We can see an example of this again from the Who Validates the Validators paper, where they are assessing various metrics for tweet generation, where given the responses, they assess whether it's a bulleted list, no made-up entities, no hashtags, and a single sentence. And we can see in this example also that the evaluation metrics that they have surfaced and find useful for this task differ greatly from a lot of the more generic ones that we see, like helpfulness or relevance, etc. The hope is, of course, that these have been identified as important, and thus improving the actual scoring of these will lead to improved quality. But by this time, once we've completed a task like this, we've done a lot of qualitative feedback collection and human annotation. The reason for this is, of course, the fact that this is our gold standard here, and human feedback tends to be the most valuable feedback for actually knowing what to improve and where our system is going right or wrong, but it is also the most difficult to consistently get. Most of our subject matter experts, as the experts they are and the busy individuals they are probably not going to want to sit down and devote most of their time to continually annotating and giving feedback to data, so we need to turn to other ways of automating and scaling this feedback collection. And this is where we switch gears and employ a technique called LLM-As-A-Judge. LLM-As-A-Judge in this case offers us the following benefit. We can scale human or human-like feedback while not needing humans. More formally, LLM-As-A-Judge essentially consists of asking a language model or prompting it to provide some form of feedback on an output based on some defined criteria. The language model will then perform an observation with optional reasoning, output written feedback, or a scalar or binary score. Essentially, it's meant to do the same actions as our human annotator, but automated. One of the core issues I see with LLM-As-A-Judge is that most teams skip over the human feedback collection step and go straight to the LLM-As-A-Judge step. They implement a few useless LLM judges and evaluators, really never get anything that is useful or actionable from these irrelevant scores, and then give up with it all entirely. But we have been working diligently and smartly and collected all of our human feedback from the prior step, and not only does this let us surface define and baseline our relevant evaluations, this gives us the foundation to then align our language model judges to our human performance so that we can do effective automation of this. Before we get into how to specifically do this, I want to cover also a couple initial pitfalls that exist with a naive implementation of LLM-As-A-Judge. As I've been trying to hammer home here, loosely defined criteria, such as providing poorly structured criteria to a judge, for example, saying something like just rate how helpful this is without defining what helpful actually means for your application, leads to inconsistent and unhelpful scoring. This is again why we do all of the pre-work to actually define all of these metrics and what they mean to us from the humans themselves. Our second point here is that for most LLM judges, we want to use a very powerful language model. Essentially, the most powerful and intelligent model that we can use that's within our allocated budget. While you may be looking at cost optimizations and using smaller or more cost-efficient models in your application, this is not the time to be doing that. I've seen commonly that cheap, small, or low-cost models often correlate with inconsistent or worse performance on actually being able to judge things. And third, another note about scalar scoring. Exactly for the same reason as to why we look for true or false, pass or fail with our human evaluators, language models suffer also from the same downfalls of not really effectively differentiating between different points on a scale. So keeping it to true, false, succeed, fail tends to provide our best outputs. And a fourth quick note is also that what we want to do is have independent language model judge prompts. So rather than having one model that assesses all of the different criteria and outputs something like a JSON object with the binary pass-fail for all of these, we want our judges to focus on just one thing, or have our prompts focus on exactly one metric at a time. The reason for this is mostly because what we want to do now is align our language model judgment performance with our human judgment performance. It becomes increasingly difficult to align a language model judge if you are trying to align multiple criteria at once. So keep these prompts independent, or keep these language model judges independent. But this is where we are going to be doing a little bit of meta evaluation here, where we want to essentially evaluate the performance of a language model and how it aligns with the performance of a human. What we of course strive to do is create a language model judge that matches the performance of the human annotator. And this goes back to why we have done this second round of annotation, where for each individual input-output, we also have for each individual metric whether it passes or fails. This allows us to take the same data set and our ground truth of the human annotator and run our language model judge through the same annotation exercise and scoring exercise. For this, it's useful to have a good mix of failures and passes within our metrics, because we want to ensure that our judge can catch both when things are good as well as when things are bad, not just one or the other. The good part about doing this evaluation is that it's a lot easier than the prior error analysis and defining and whatnot, because we can use some common classification performance metrics and inter-rater agreement metrics. Given our dataset of pass-fails for each individual metric, we can compare then the language model performance to the human performance to calculate where we have true positives, true negatives, and false negatives. With this, we can do all sorts of stuff. One of the more common inter-rater agreement coefficients that we could use is Cohen's kappa here, which measures the inter-rater agreement while correcting for chance agreement. Looking at our observed agreement minus our expected agreement all over 1 minus the expected agreement, we get a value between -1 and 1. We interpret this as such, where something around the range of 0.2 to 0.4 is fair agreement, and something around the range of 0.6 to 0.8 is substantial agreement. The scoring may seem a little bit conservative, as we would normally with things like accuracy want something like 99.9% accuracy, but the idea behind this is that most people really just don't agree. It's rare that even if you do have multiple annotators, that they will all directly agree with each other on these. So having something that's a little bit like 0.6 to 0.8 in the Cohen's kappa coefficient represents substantial agreement and is usually good enough for our alignment. On top of our Cohen's kappa, we can of course also just use standard classification performance metrics like accuracy, precision, recall, F1 score, specificity, etc. To actually improve your language model judge and do this alignment, a little bit of it is mostly trial and error at this point. You can do things like prompt engineering, add in few shot examples, showing example annotations. You may be interested in looking at different prompt optimizers if they work for you. Essentially, at this point, do what works until you have a sufficiently trained judge. There's no right or wrong answer at this stage. You would then repeat this for each dimension of your total evaluation rubric until each one of your LLM judges is sufficiently aligned with the performance of your human feedback. So now you should be able to efficiently scale and automate the feedback process through language models. And we know that this is a useful measurement because they've been aligned specifically to the definitions and feedback that we have gotten and surfaced through our human feedback from our subject matter experts. As a quick side tangent, it's not necessary to actually use language models for all of your scoring. Simpler or more straightforward tests still can be done with just straight functions or assertions. For example, if you have something like specific formatting where you always want a link to be in Markdown format or something, it would be a lot easier just to check that this is true or false with something like a quick regular expression-based function. Other simpler assertions, like whether or not a subject has been referenced or not, or the existence of a code block, all can be done with something that looks a little bit like this. We do, of course, want to make sure that this is outputting something that is true or false, as this is, once again, going to be an easier signal to interpret and optimize against. I've also seen functions being used as something that I call a quantitative proxy for human preferences. Essentially, a function that can represent effectively a qualitative feature that is being desired. For example, something like verbosity levels can be approximated by checking the length of the output, or we can do things like check engagement or tone through counts of exclamations or the use of first second pronoun ratios. I've also seen semantic similarity via embedding based similarity calculations be applied, mostly to check if things like your output to a question, the answer is relevant back to the question, or more commonly, if the output is relevant to something that has been retrieved from a RAG system. This may give an indication of how on topic a response is. A couple words of warning, however, on this last one about semantic similarity. I would say it's less of a definitive check and more of a check in direction of whether or not you are performing well or poorly. It doesn't necessarily tell you exacts here. It's difficult to interpret. And then, of course, as with all of the testing that we've been discussing, we would still want to make sure that our function-based estimates are in agreement with our professional opinions. But in practice, we often use a mixture of language model judge and function evaluations across our various evaluation rubrics. We apply these functions for straightforward and simple checks, whereas we employ language models for fuzzy or reasoning-based scoring. And we trust all of these because we have done the diligent pre-work of collecting all this feedback and definitions from our users, and then aligning all of our functions and judges to what the expected annotation from a human is, which allows us to apply these with some confidence towards additional unseen queries. To call back to our example of the web search tool, I might create a function evaluation to parse and check against common filtering patterns while relying on a language model's judgment to assess whether the query itself is high quality. The definition of high quality here would have been defined as I evaluate it and then align the language model judge towards my performance. So with all of our metrics defined and now able to scale via functions and language model judges, what you're probably wondering is what platforms or software kind of allow this. And this is largely addressed by these new suite of platforms that offer language model observability. You're probably already employing these if you are doing active language model development, using things like Langsmith or Langfuse, which offer you a view into the trace of a language model. For an example, using Langsmith here, these are the tools that allow us to see exactly how a model's behave, the inputs, outputs, and all of the steps along the way. Many of these platforms, Langsmith included, offer a way for you to do the definition of these metrics as well as run these automated experiments on datasets directly within the platform. They do, however, come at a price generally based on the number of traces that you are storing or pushing to their observability platform. Something else that I've seen and participated in is that occasionally it can also be useful to build custom visualization and workflow tools depending on how you best interact with your data as well as your stakeholder team to run these experiments. For example, I've built and open sourced this platform called Evaluizer. I built this platform specifically for my style of workflow where I can upload datasets of specific inputs that I want, run them through prompts and record down their outputs, and also provide some sort of annotation and evaluation. So I can say whether or not I liked or disliked something, add in feedback in an open feedback bar, as well as run my various metrics. So for example, I have an exact match function, or down here, I can add in a language model judge function. This helps me do, to some degree, all of the different things that we've talked about with human feedback and annotation, as well as helping to align both our function evaluations and our language model evaluations. At the same time, I can very easily use things like versioning to keep track of what prompts I'm using, as well as see how my different metrics are performing across various prompts and datasets. As a plus, I've also implemented an algorithmic prompt optimizer, which we'll talk about here in a second. If you're interested in using the platform yourself, you can check it out on GitHub. I'll have it linked in the description below. But to cap off on the observability and actual implementation of this, I would say your choice of platform depends on what level of sophistication and how many dollars you're willing to spend. So if you need all the bells and whistles, running offline and online evaluations with monitoring, plus all sorts of other features, things like Langsmith has you covered for a fee. If you're looking to just get straight results with quick annotations and experiments, maybe you can just use pandas and Excel. Nothing ever wrong with that. Or if you need something custom, you may want to check out my platform or build something similar to Evaluizer. Whatever your choice, there's no wrong answer here. It just depends on what works best for your style. So with all of this human feedback and then language model judge and function definition, as well as integrating it nicely into an observability platform of our choice, what we have done is effectively set up and defined our evaluation suite for our AI product. What we hope to uncover is that now we know what matters to our stakeholders, we know how to measure what matters to our stakeholders, we've also made a good friend with our hostage annotator here, and then we can, of course, automate and continually monitor performance that actually matters for our system, which can help us to identify and mitigate failure modes that may lead to low trust. This lets us make very clear and informed decisions on how to improve and where to assign our resources on the development of our AI product, as well as when we make a change, we can measurably tell whether or not that has improved or worsened the performance of our product. This helps propagate through not just our technical goals, but also our broader business goals and alignment with our end users. On top of course, all of these benefits, there are a couple emerging fields that I've seen that can also benefit from doing all the pre-work of setting up and defining evaluations. The first of which is algorithmic optimization, which at its core is essentially not just trying to automate the measurement and evaluation of a system, but also extend that towards automating the improvement of the system itself. This is what frameworks like DSPy actually offer, where they implement various different algorithms to automate prompt refinement given a dataset and some sort of metric to hill climb and improve. They employ various optimization algorithms like automated few-shot learning, MIPRO, or genetic Pareto, or JEPA, which is visualized right here, to more consistently improve language model performance by optimizing the prompts behind the scenes. Where this comes into play is that the biggest barrier that I've seen to adoption with DSPy has been the need for actually having defined metrics and a data set of different training examples to run through. This is what is required for a lot of these algorithms to actually work, but as we've mentioned over the course of this video, that most often when we sit down to create a language model-based application, we most often don't have these sorts of metrics or data sets ready to go. This is where all of the different pre-work that we've done can come in, because we've essentially laid this foundation where we can take advantage of these more automated and advanced systems. And with automated improvements and automated metrics, this brings us closer to the idea of self-evolving or self-improving agents. This is the idea that with all of our robust evaluation, we can continually monitor and trigger improvements to our systems when we see these evaluations fall below a specific threshold. One of the proposed ideas here is that we have a separate language model that is able to create a new prompt at this time, run it against a testing set to see whether or not the prompt improves or degrades performance, and then automatically apply that update into the agent itself. From my experience and observation, actually doing this is still relatively nascent. I can see this becoming more reliable and more popular as the models and frameworks to do this stabilize, but in its current maturity, I am more keeping tabs on how this is being applied and the research around it, rather than directly implementing these self-improving loops myself. A second popular growing field that could also use some of these evaluated and defined metrics is also that of reinforcement learning, where in the context of all of this evaluation defining, these evaluation functions themselves look very similar to reward functions. We can then employ a reinforcement learning training loop where the language model will try and perform the task on the dataset that we provide. Our environment, which is this task, will then return a reward. The reward will of course be calculated based on our evaluation metrics, and then we can directly fine-tune and update the weights of our model based on the rewards there. The expectation then is that the language model and the reinforcement algorithms will try and learn a policy, or of course the language model behavior here, to maximize these rewards, thus propagating all of our metrics and what we hope to be effective measurement directly into the weights of the model. As a word of caution, reward modeling and reinforcement learning is not as easy as the two lines that I just said, so don't take this as an exact or a given. But we can start to see how this could be used for some fine-tuning, or if we even wanted to, we could start to instill some of the expected behavior that we want into a smaller language model. Generally, we would be relying on some sort of larger language model, but there are some efficiencies to be made if we can directly train a small model on our rubric here to be able to perform as effectively as a larger one. This can, of course, bring all of the efficiency gains and cost gains that come with running a smaller language model. But if you're interested in learning more about how reinforcement learning is applied to language models and how I do it myself, you can check out my other video on RLVR or check out my blog on the same topic on my website. So with all of the benefits and all of the work necessary to get there articulated, I also wanted to take just a brief second here at the end to talk about what's next with all of this, or all of the things that you need to consider going into the future. The first one relates back to our criteria drift phenomenon and extends it more towards how our products evolve themselves. What I've seen is that as our applications evolve, it's certainly worth revisiting the individual steps in feedback collection exercises to ensure that we are still in line with what our users want and effectively measuring the performance. So as mentioned, the first thing that I do to help with this is doing active and very proactive continual surveying and feedback collection. Even when you make it very easy to give feedback, things like a thumbs up or thumbs down on a chat for a chatbot or an agentic assistant, most users, I feel, are not very inclined to spend the time actively providing that feedback. More often or not, they just close the tab and leave. So what I do is I very proactively solicit feedback and do surveys with end users as well as SMEs or wider networks of SMEs to help me both discover new or underexplored failure modes, ideas for additional features, and continually get a baseline of user satisfaction. On top of all of this, it's worthwhile looking through and re-annotating your metric data sheets to see and make sure that they are in line with current opinions and current functionality of your product. On top of staying on top of things as things evolved, this also just helps with general trust building and setting your future direction. And secondly, as you release different versions of your product or make different improvements, what you can do is also do pairwise experiments. This is going to be taking the same input list and running them through the version 1 and the version 2 of your product. And then of those two outputs, you ask your SME to annotate which one they prefer. This can help uncover unseen regressions or maybe unexpected emergent improvements, as well as definitively say which version actually is improving. And if you're really sophisticated and have enough data, you could even set up a pairwise language model judge that is aligned with your SME. But the big idea behind this future checklist that I call it here is to just continually do these exercises. It's not really a one and done kind of situation. You want to continually gather this feedback, run annotations, do surveying and testing to make sure that you're still in line, or maybe even address or redefine the different definitions of your evaluations, remove some if they've been saturated, or add in new ones as they may emerge. If you've made it this far into the video, you're likely thinking, this is a lot of work. Is it worth it? And I would argue that it actually really is. As I put here in the end, that keeping up with the evolving needs of your users, surfacing your domain-specific metrics, working with your subject matter experts, and applying these very carefully planned out evaluation frameworks all help to assist in guiding effective and measurable improvements to your system, while also building trust and buy-in from your users. Through engaging early on with your SMEs to discover these failure modes and judge outputs, we can effectively align our evaluation strategy directly to what would give us the most relevant improvement path. This is further scaled through using our aligned language model judges and our related test functions, which can help us do the automated scoring and uncovering of direct insights into whether or not our product is performing in an expected manner and whether a change actually leads to an improvement or not. This gives you a clear, measurable direction for the development of your language model-based product and can lead to more successful implementation, scaling, and adoption. So whether you go through the rigor of setting up a full evaluation suite or not, actually understanding the purpose and benefit of these application-specific evals will help you make more informed decisions in the future of how to develop and improve your AI products. So with that, I'd like to give a special thanks and shout out to Hamal Hussain, Eugene Yan, and Shreya Shankar, whose blogs and work heavily inspired the contents of this blog, and also over the couple years has affected the application of all of these concepts back into what I do every day. And speaking of blogs, if you're interested in looking at all of this content in a written form, you can see it posted as a blog here on my personal website, linked in the description below. And with all that being said, hope you learned something interesting today. If you liked the video, go ahead and like the video. If you want to see more like this, consider subscribing. And if you have any thoughts or comments, leave them in the comments down below. Thank you and have a great day.